Have you ever looked out of the window while in a moving car and noticed that the objects that are further away seem to be moving slower than those close to the car? How can that be true if you're moving in a straight line? In this video, we'll explain this phenomenon to you with a simple thought experiment. Imagine standing on railroad tracks, looking forward as seen in the picture. We know for a fact that the left and right rails are parallel to each other. However, the way we see it, the tracks appear to be ever so close to each other. On the railroad tracks, you can see two tables, one close to you and a second one further away. These tables are the same size. To our eyes, however, the table in front looks wider. Now, let's put a car on each table. The cars are identical in size and drive with the same speed. Both cars begin moving with the same speed simultaneously. They arrive on the other side of the table at the same time. It appears, however, that the car further away is moving slower. The movement of the car closer to us can be described with the basic equation for speed, where S1 is the distance the first car appears to travel and V1 is the speed the first car appears to have. The movement of the car farther from us can also be described with the basic equation for speed, where S2 is the distance the second car appears to travel and V2 is the speed the second car appears to have. We know from observation that both cars arrived on the other side of the table at the same time. Therefore, time, t, is the same in both equations. With some basic rearrangement of the two equations, we can see that the apparent speed of the car is proportional to the apparent distance it traveled. Therefore, the car that appears to travel a shorter distance appears to be moving with a lesser speed. This makes sense, as it would need to be moving slower in order to travel a smaller distance in the same amount of time. Now, all that's left for us to remember is a basic principle in physics. The world appears to be the same to somebody moving at a constant speed and to somebody standing still. Therefore, we can imagine that us moving in a vehicle is actually us being still and the world moving around us. Now, the same effect that is clear for the two cars is applicable to any object in our line of sight.